All right, so this is nothing new to you guys, right? We identified the reciprocal identities. In other words, well, we've looked at it from this perspective. Well, actually, we looked at it from this perspective, right? We know that cosecant of theta is the same as 1 over sine of theta. And if sine is in the denominator of a fraction, then obviously it can't equal 0. And so we know that when we looked at the graph of cosecant, there were vertical asymptotes that occurred when sine equaled 0, right? And so I'm just going to pull that. I'm going to pull that up in Desmos real quick so we could see it, and I'll take a screenshot. So what we're saying is sine of x is this thing here, and then when I say cosecant of x, I get this. All right. So one of the things that we've kind of glossed over, well, I shouldn't say gloss over. I've said it. I don't know if you guys have memorized it because I've only said it a handful of times and you haven't really practiced this a lot. But when I look at this graph, and I'm going to have to make this kind of small. And we'll zoom in on it. Everybody has that stuff written down, right? Notice that when sine equals 0, so the red thing is sine, right? The red graph is sine. Notice that when sine equals 0, there is a vertical asymptote. In other words, sine cannot equal 0 for cosecant. The blue graph is cosecant. So those are the values, those are the domain restrictions for cosecant, right? And I should probably write this down. So the red graph is sine of x, the blue graph is cosecant. Okay, that's the first one. And I'm not going to put all the graphs in there, but I just want one visual illustration as to what happens when we do the graphs. Same thing here. For secant is the reciprocal of cosine, or secant can be 1 over cosine. Cotangent is the same as 1 over tangent. So these are the ones that we've kind of been using, but they're interchangeable, right? They're reciprocals of each other, which will be helpful. Now, the other thing that we need to do is learn how to apply that. So let's do an example together real quick. So for example number 1 on this section, we want to find cosine if we know what secant is. So remember that secant of theta is equal to 1 over cosine. No, wait, is that right? Yeah, 1 over cosine. And I'm asked to find that. But what did we say secant of theta is? Well, secant of theta is equal to negative pi. So I say negative pi is equal to 1 over cosine. So from here, if I look at this, if I look at just this section right here, I can solve that algebraically for cosine, right? So how do I do that? Well, I'm going to multiply. I got to pull this cosine out of the bottom. So I'm going to multiply this by cosine of theta. And whatever I do on one side of the equation, I got to do on the other. So cosine of theta is a number when you think about it, right? Whatever theta is, I don't know what theta is, but it represents two sides of a triangle that we know exists because they gave us a value for secant. So then I'm going to multiply both sides just like I would a number. Well, these will cancel, and I get negative pi, we always want to write the numbers in front of the trig functions. Negative pi cosine of theta is equal to 1. Now I'm solving for cosine, so I just need to divide both sides by negative pi. So then I get cosine of theta is equal to 1 over pi. Now I've kind of taken the long route to show you that that's the answer. But I could have just reciprocated it, right? I could have said that if secant of theta was equal to negative pi, I could have written that as negative pi over 1, right? And just said cosine is equal to 1 over negative pi. Just reciprocate the values, right? And I can kind of do the same thing with sine. If I say that cosecant of theta is equal to the square root of 6, can I write that as the square root of 6 over 1? So then what would sine be? Well, that would be 1 over the square root of 6. I can't leave it that way, though. I have to multiply this by the square root of 6, multiply this by the square root of 6. And I get root 6 over 6. Any questions?